Hello, welcome back. I wanted to summarize our discussion on the Miller-Rabin primality testing. So far, we have proved that the size of the bad set is less than or equal to half of the size of the Z star n. That means if n is a composite number, there is a high probability that we will find some evidence to show n is a composite number. So we will very likely not declare that number as a prime. That's what we have proved so far. Okay. Recall the fact that Z star n is the group that we are working with. And we proved that there is a small set called bad. The size of the bad cannot be more than Z star n by 2 because we found a subgroup called bad prime, which contains bad. And by definition, subgroup cannot have more than half of the elements. Okay. We also proved that. That's the reason why bad has to be bounded by half of the size of Z star n. Okay, which is really good. Suppose n is a composite number and we randomly choose a strong witness. We expect that a strong witness will be chosen outside the bad boundary. Okay, that's basically the expectation. And what happens in the worst case? Every time we select an element from bad, what is the probability we select an element from bad? Well, at most 1/2 in each iteration, because we said half of the elements are bad for composite testing. So we do it t times. That means all of the trials are independent. So we'll have 1 by 2 power t. And if we make t to be large enough, for example, t to be 80, then 1 in 2 power 80 possibility or probability that a composite number is wrongly declared as prime. Okay, you can, 80 is so large, 2 power 80 is so large, you can even live with 40, for example. That means 1 in a few billion will be wrongly declared as a prime. Okay, if the number n is composite, there's very less chance that it will be declared as a prime.